Okay, root 8 divided by 2 root 24. So always remember that's like a 1 root 8. So my numbers are 1 and 2. I can't divide those, but root 8 gets grouped with the root 24, and I'm going to take the GCF out of both of those. So what goes into 8 and 24? Well, 8 does. So I'm going to go root 8 divided by root 8 and root 24 divided by root 8. So root 8 divided by root 8 is just 1. You can say square root of 1, but the square root of 1 is 1. So it's just 1. Root 24 divided by root 8 is root 3. So I end up with 1 divided by 2 root 3. It's also important to notice that because I'm dividing by root 8, I don't touch the 2. So the 2 just comes along and it's 2 root 3. And then we're kind of stuck. The 3 doesn't break down with any of the tricks we have. But a rule with radicals is that you're never supposed to leave an answer with a radical in the denominator. So that means in the bottom. You're not supposed to leave an answer with a denominator that has a root in it. So to get rid of a root in the denominator, we actually multiply top and bottom by just that root. So even though the denominator is 2 root 3, I'm going to multiply top and bottom by just the root 3. I do top and bottom because anything, as long as it's the same in the top and the bottom, it's really just a 1. Root 3 divided by root 3 equals 1. If we times something by 1, it doesn't change it. So it's kind of similar to getting a common denominator. So I'm going to have 1 over 2 root 3 times root 3 over root 3. And so I get equals 1 times root 3 is root 3. 2 root 3 times root 3 is 2 root 9. Now, this is kind of like an in-between step that you might want to skip in the future because there is a shortcut because I know what 3 times 3 is. But I'm going to break the 9 down and I go, oh, it's 3 times 3. Well, of course it is. I just multiplied root 3 by itself. So the 3's come out of the root sign, leave nothing, and it's just a 3. So this equals root 3 over 2 times 3, which is root 3 over 6. So we call this rationalizing the denominator because a square root is not a rational number, it's irrational. So we're getting rid of the square root in the denominator. So we call this process rationalizing the denominator, and we'll talk more about it pretty soon. So it's important to notice again that we could have skipped this step, and you can kind of see it, that you got that root 3 in the bottom times the root 3, it just equals 3. So we don't have to write that in between with the 2 root 9. Anytime you multiply a root by itself, it just equals the number. So root 2 times root 2 is just 2. Root 8 times root 8 is just 8. So that's how anytime if we want to get rid of that root in the bottom, we just multiply it by itself.